The goal of this video is to demonstrate the affine transformations in the shape machine. So first we draw a rectangle and we draw a second shape to connect the midpoints, making a rhombus in Rhino. And we can see that the two shapes register as two objects in Rhino's data structure. And we're going to draw a second shape on the upper left corner of a small square and a nested square. Because they're constructed in the same way, theoretically, all the shapes embedded in the smaller reference shape are related under affinity to the larger design. So when we start by drawing this triangle on top of the template structure, the shape machine should be able to match that triangle under affinity in the design on the right. And we can see with the red highlight that the match is successful. When we select a triangle that we want, we can cut it and pull it away from the original design. Now in the second example, we're going to draw a square on the template. Under affinity, the square can map to the rectangle, like the first match, or the rhombus of the second match. So essentially, the small template has two squares, and under the affine transformation, one can relate to the rectangle and the other to the rhombus. In the third example, we're going to study pentagons. So we start by drawing this kind of open envelope pentagon on the reference shape. And we can see that in the reference shape there are four of this pentagon. So under affinity there should be four in the larger design as well. And the shape machine can find each of the four pentagons embedded in the stretch shape under the affinity mapping. And even though these pentagons look slightly different to our eyes, because they have the same relationship under affinity, the shape machine will recognize them as equivalent. Moving to the fourth example, we'll look at a hexagon. And we can see that there are two hexagons in the reference shape. And the shape machine can find those two hexagons under affinity in the stretched design as well. The point in this demonstration is that if the whole geometry is related under affine transformation, like the example of the design in the reference template, then the parts embedded in the geometry can also be related under an affine transformation. In this last example, we'll look at one more type of pentagon, this kind of house shape. And this also has four matches in the reference shape. And the shape machine can find that affine relationship between the one we've drawn on the left and the design on the right.